A farmer is growing a field of wheat plants. The height, h centimeters, of each plant can be modeled by a normal distribution with mean mu and standard deviation sigma. We also know the probability that the height is less than 94.6 is 0.288, and that the probability that the height is greater than 98.1 is 0.434. Now, we're going to do part B since we already did part A previously, which is to find mu and sigma, right? To find what the mean is and to find what the standard deviation is. So the way we do that is by using things that we already know regarding the normal distributions, because all normal distributions can be put into the standard normal form, and therefore we can figure them out. So what we're going to do is we're going to use the inverse normal to find at least one z-score for p of z is less than z for both of these. So what we need to find on our z-score table or z-score table is we need to find probability that z is less than a specific z being 0.288. And then we need to figure out the probability z less than z for 1 minus 0.434, right? So the opposite of 0.434, which was the other one we got here, right? Notice I switched the sign. I switched it to the less than sign because that's how the z-score table is represented. And that's why it's 1 minus this value, right? Because the opposite of the height being greater than 98.1 is the height being less than it. And so therefore the probability is 1 minus, the probability of the affirmative. And so that's why we have to switch both those things. Okay, so let's say that we look on our z-score table. What do we find? We're going to find that z1 is equal to negative 0.559236, and that z2 is equal to 0.166199, like that. So therefore we know that the z-score in general, recall that the z-score in general is equal to the number x minus the mean mu over the standard deviation. So that means we need to figure out the standard deviation and the mu, given that 94.6 minus mu over the standard deviation must equal to that first value we found of negative 0.559236, etc. And also the next one, which is 98.1 minus mu over the standard deviation, is equal to 0.166199. So we need to solve these equations and figure out what mu and standard deviation is going to be. Probably the easiest way to do this, I would say, is going to be to multiply both sides by standard deviation, kind of swap these, and then go from there. So for instance, we could say, based on like this first equation here, that mu is equal to, sigma is equal to 94.6 minus mu over negative 0.559236. And then also standard deviation must be equal to 98.1 minus mu all over the 0.166199. And then we can equate these two together using substitution. So 94.6 minus mu over negative 0.559236 is equal to 98.1 minus mu over 0.166199. And then we need to just solve for mu. So if we solve for mu, we're going to end up with approximately 97.3. And then we're going to plug that value back into either here or into here, doesn't matter which one, to figure out that the standard deviation is about 4.82.